Hey guys, welcome to day one of my free networking course. My name is Tando, and you're about to embark on an exciting journey into the world of networking with network coders. Thank you for choosing to start this journey with me. I trust that you'll find this course both enjoyable and informative. So, by the end of today's lesson, you will have a solid understanding of what a switch is, the role it plays in the network, and configuring network devices in the network. We'll also be using Cisco Packet Tracer to visualize some of these concepts. So let's get started. Before we get into the video, you guys have been watching my videos and haven't been subscribing. So please do the right thing. Subscribe, comment, and switch those notification bells on so you never miss an episode. Let's get into the video. So in last week's episode, we really spoke about what a network is and the different network components that are connected in the network. So if you didn't check out last week's episode, please do and check out the amazing insights that we have about networking in general. So, in today's session, we are going to be breaking down what a switch is. And if you remember, in the last episode, we said a switch is a network device that connects other network devices together, such as clients and servers. It also has a logic where it remembers different MAC addresses of the different components that are connected in the network and also handles the transmission of the data, sending from the source MAC address to the destination MAC addresses. So I'm sure you don't want to miss out on today's session. Please stay along. So in today's session, we are going to be using Cisco Packet Tracer. Shout out to Cisco for developing this wonderful application for us so that we can be able to simulate the transmission of our data through the network. So in today's session, we are going to be building a small network which comprises of two PCs. So the nice thing about packet tracers is that it allows us to interact with different devices and also menu options on top. So I'm going to be choosing end devices, which is a PC, and I'm going to choose another PC, and then our star of the show, which is an end device, a switch. So we have three components at the moment that we are going to be using for today's lesson, and connecting these three network devices, I'm going to be using a copper straight through cable. So I'm going to be connecting it from the PC to the switch using a fast Ethernet cable, and then I'm going to do the same for the second device using fast Ethernet to the switch. So now to actually facilitate the connection and the sending of packets, you actually have to to configure the PC so that they can have IP addresses and be known in the network. So if I click on this PC, a pop-up shows up, and then I can actually have the ability to interact with a lot of the tools within this window. But now I'm going to be looking at the desktop and then the IP configuration. So I have two options to assign a IP address to a device. So in this case, I'm going to be choosing static so that I can manually input the IP address. But if I were to have a DHCP server, for example, I would be having the DHCP server automatically assigning that IP address to the device that I want the IP address to be assigned to. So for now, I'm going to be using a Class C IP address, which is 192.168.10.2. And then the subnet mask is automatically assigned to that device. And then I'm going to close this one, and then I do the same thing on this one, which is configuring the IP, which is 192.168.10.3. Then the subnet mask automatically assigns for this one as well. and I close that one. So if you notice that there are four green triangles, I don't know what they are, but it shows a connection that is good so that we can actually send packets. So what I'm going to do now is actually move this LAN network to the side so that we can look at another cool feature of Packet Tracer, which is the simulation tool. So the simulation tool is actually powerful in terms of monitoring the network activity. So if I would send a packet from PC1 to PC2, I would basically be selecting this packet, which is actually a message, and click PC1 and then click on PC2. So if you notice on the side panel, you get the ICMP and the ARP. So this simulation panel has a log so that you can actually see what is happening in your network. So I'm just going to press the play button so that you can see how that packet flows from PC1 to the switch, from the switch to the destination PC. So if you notice that it goes to the switch and then it goes to PC2. And then another fascinating thing about this now is that it's going to send that packet back to PC1 to show that it's actually got it. So it's basically replying to PC1 and saying, "Hey, PC1, I've actually received your message. So thank you for that." So that's a really cool feature of Cisco Packet Traces, that you have the ability to interact with the loads of tools that you can use to monitor your network and also create different networks, because this is only just a small LAN network for the purpose of the lesson today. So what I'm going to do now is I'm going to take that away, and then on PC1 what I'm going to do is, well, not PC1, but the star of the show. How can I forget about the star of the show, which is the switch? So I'm going to go to the switch, and what I'm going to do is go to its command line interface. So what we are actually doing right now is picking the brain of the switch and looking what it has in store for us. So what I'm going to do is going to click enter, and then now I can interact with the brain and say and actually type enable, enter, and then what you should see on your screen right now is that you have a switch and a hash key. So another powerful command that I'm going to use now to actually show us what we're actually looking for inside the switch's brain, I'm going to show MAC address table. Voila. So if you notice now that you get two MAC addresses, so these MAC addresses actually belong to the two PCs, PC1 and PC2. And if you look at the right hand side, you see that there are ports. So PC1 is actually connected to port 1, and PC2 is connected to port 2. So the nice thing about this command line interface of the actual switch is that it shows us a cam table. So what a cam table does is basically record the MAC addresses of the devices that are connected to it via the ports. So it once there's a connection between the PC and the switch and other devices, it will now check if what device is connected on which port, and then when it receives a packet, it knows exactly where to send that packet because it has recorded each and every MAC address that belongs to the devices in the network. So that's really, really, really awesome, guys. So now I'm going to actually try and ping PC2 from PC1's command line interface. So that's another cool feature that I want to show you guys today. So I'm going to quickly close the switch's brain and then go to PC1 and open the command line And then I'm going to use a nice feature that network engineers use to actually see if other pieces on the network are alive and connected and responding. So I'm going to say ping 10, nope, not 10, but 192.168.10.3. So if you remember the IP address of PC2, it was 10.3 at the end. So what I'm trying to do is to check if PC2 is connected into this network. So when I ping, wow, look at that. So it replies with the packets saying that, okay, I've received a packet and I just want to acknowledge that I received the packet. So basically what we analyzed today is how the switch works and what um, type of protocols it uses. And also the nice thing is that it uses its CAM table to record the different IP addresses and make sure that it relays and transmits all the data that it needs to the correct destination. So now I'm going to show you a nice feature that outlines the different layers of the OSI model. So the OSI model is basically different layers of the network that has different protocols so that to track and monitor the different um, network traffic that is in the network. So what I'm going to do now is close this one, and then what I'm going to do is actually put that packet back onto there, and then click on PC2 again, and then obviously bring up our simulation tool again. So I'm going to double click on there. So we have a nice window which shows us the different layers of the OSI model. So in layer one, we have the, okay, let me just resize that a bit. So in layer one, what does that keep? Okay, let me do this. Okay, that's great. So if you notice, wow. So if you notice on layer one, you get fast internet. So that represents the network cabling. So in layer two, you get the different MAC addresses. So the MAC address that you get first is the source MAC address and the destination MAC address. And then in layer three, which is so fascinating, is now you get our IP addresses that we configured earlier on. So you get the source IP address, which is 10.2, and the destination IP address, which is 10.3. So that's what we are actually going to be covering more in the next sections because we are going to be taking a deep dive into the OSI model and checking what the different layers has in store for us because these layers are very, very important when diagnosing what's happening in the network because you can also use different tools. For example, Wireshark. Wireshark actually breaks down all these seven layers. Network engineers have the ability to monitor the networks and be able to give reports on the different network activity. So the key takeaways from today's lessons were what a switch does and its role in the network. So now we know that a switch has a CAM table which it uses to record and memorize the MAC addresses of the PCs or devices that are connected on the network, and it also is in charge of handling the transmission of the data, making sure that when a packet is sent from a source device, it can reach its destination device because it already remembers where that device is connected. So, what's really important for you guys to understand is that a switch is a device that connects other devices in the network and is responsible for carrying out those data packets to the destination devices. So, I hope you guys learned as much as you could in this lesson. So in the next session, we'll be focusing on more network devices, and then in a later stage, we're going to be looking at the OSI model, which is important for network traffic monitoring. So see you on the next one.